Hi guys, in this video we're going to recap titrations, look at the manganate 6 ions as an oxidizing agent, we'll look at iron 2 ions in the potassium permanganate titrations, iron 2 ions in the potassium dichromate titrations, iodine in the sodium thiosulphate titrations, unknown redox titration questions, and then finally we're going to summarize.
You should remember that titrations are used to find unknown concentrations of substances. So, for example, in another video we've covered how they can be used with acids and bases. The equipment is as follows. We have a burette shown here, which has fine divisions on it, so that we can very gradually add whatever solution is in here to the solution in the conical flask here. We want to know exactly how much we have to add of the substance in the burette to react fully with the substance in the conical flask. We have a known volume in the conical flask because this way, if we can calculate the number of moles of a particular substance in it, we can use the reaction equation for whatever reaction is taking place. So with acids and bases it was neutralization, and that way we can calculate the concentration of the liquid in the conical flask. If you want to see these calculations in action, rewatch our titration curves video. So now we've recapped titrations, let's look at titrations involving redox reactions. In our video on redox reactions, we saw that the manganate 7 ions are readily reduced to form manganese 2+ ions. This happens in acidic conditions. You can see the equation for it again below, where we have the H+ from the acid reacting with the manganate ions. They're taking on 5 electrons as they're reduced, and then we're left with manganese 2+ ions and water. Usually we use potassium permanganate as a source of the manganate 7 ions. The per in this word is an old-fashioned way of signalling that the oxidation number is 7, but you don't need to know this. The reason that potassium permanganate is a useful oxidizing agent for titrations is that the manganate ions are a different colour to the manganese ion. Before the manganate is reduced, the manganate ions have a distinct purple colour. However, afterwards, the manganese ions, Mn2+, are colourless. So we can use this colour change as an endpoint in a titration. Now we know how permanganate can be reduced, let's look at a common redox titration that you will need to learn. We'll see how the oxidation of Fe2+ ions...
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.